So we will continue from where we left off now, and one of the things that were cool in the Houdini 17 whitewater solver was the foam preservation. So not to change many things in this scene, I will show you what I mean. So if we open a new Houdini and just maybe create the regular ocean flat tank, let's create a flat tank, and then the whitewater itself. Okay, all right, so whitewater solver, I think it was in, oh no, it's not in here. Whitewater sim, where did I find it? It was somewhere here, I think. Control F. Foam, surface foam, compute. Oh, I think it was in the maybe it was in the, I think it's in the foam solver maybe. No, I think it was in the, let me delete this, sorry, maybe it was not a good example. I think it was in here. I think it was in here, yes. Dive in here, apply the preserve form. Okay, yeah, so based on the density of the particles within a certain radius, this changes the particle lifespan. So that's exactly what I did. I said, okay, this might come useful. So just fetch this guy from there. So if you just go allow editing of contents, and then you can dive inside and go inside the foam sim and just copy this guy to our own scene here, and that should do the trick. We need to, of course, disconnect these referenced values. So since this doesn't change the position of the particles at all, so it just adjusts the lifespan, so we can use it after we snap the particles on top of the surface. So let's give it the same color, because then the same thing, and let's give it the values that I used in my scenario. So radius scale is by set 4, minimum foam 2, maximum foam 8, preserve rate 0.85, and reduction rate 0.05. Okay, now in the, after this we need to bring in our land collision geometry. So let's drop in a merge node after the solver, and let's put in a static solver. Well, I mean, the documentation says the static solver is not necessary, but I think I use it for organization reasons. It's easier. So on merge 4, we want left input to affect right input, so it's set to collide relationship. So on top of the solver, we're gonna put a static object, plug this guy to the left input, and let's name this to land. So in case we get some particles going through there, they can bounce off and do something more interesting than just not doing anything. Let's pin this guy here, change the collision bounce to, under the physical tab, change the bounce to 0.25 maybe, and select the foam as well because they work together. In physical, I think this can be set to 1, 0 friction. I think I like to leave some friction. I have changed it 0 in my scene, but let's leave it to 1. Maybe, okay, let's bring it down a little bit. So because it's 0, let's go half, 0.5. Okay. Okay, so let's select the collision object again. Go to the collisions tab. Change the mode to volume sample and division method to by size, and change it to 1. So now we need to bring the geometry and the proxy volume, and because we nicely categorized all that under environment 1, we're just gonna dive in there. Oh wait, okay, so this is our collision VDB, just comes here, and our proxy geo goes there, and that should do the trick. Let's change the visibility to proxy geo, and our render flag to render, so we don't forget it later. Okay, so now we are missing only the one thing, which is the boat, before simulating. So now I'm just gonna put my cleanup nodes. So first thing I want to remove is anything but what I need, and that means everything but ID, age, life, and rest. Okay, and then you will see that just removing a few attributes. So even in this first frame, we have 25,000 particles, right? And we have like 21 attributes and 6-point groups. So our memory is 2.80 megabytes, and now 913 kilobytes. So it's very important to do these little things. And then let's remove the groups because these are all whitewater to our knowledge. If you guys want to keep some more control, obviously you don't need to. You can use this for creating some other things. Okay, and I have something here, but I'm not sure what I'm doing with it. Okay, v equals p displace equals p. That's strange. Okay, well, let's drop in an attribute wrangle. Sometimes I just leave nodes that I create some attributes and I never use them. Let's set the p scale to 0.16. Again, this is all liquid related, camera related, so this p scale might be not enough or might be too big, depending on your shading. All right, so here's one thing that I have, since it is like almost one of the first simulations. I'm gonna drop in a Python node. So this might just work fine or not work fine in Linux and Houdini. It's because you might have to install a library called psutil. As a matter of fact, I'm just going to check that now. How to install psutil, and PyPy probably would do the trick. And installation. Okay, here's a guide for Windows, here's a guide for Linux. Okay, so I am, as a matter of fact, gonna demonstrate now this on both systems. Well, I already have it on Linux, and the way I know that I have it is that if I open Python, I can say import psutil, and it does an error. That means that I have it. Why? Because this guy can print out certain information as simulation is going. It's just a little part of introduction to Python in Houdini, you can say. But how do we check how to do this in Windows? Luckily, I'm prepared for that. I am using, what was the application's name? VirtualBox. And I found a way to boot into my Linux partition. So that's what I'll do now. So basically, in this little box, my Linux machine will load instead of my Linux. So it's easy. It's not like a virtual disk that I installed Windows on, but it's actually my other partition that has the Windows on. It's opening. So we can follow these steps to see if it's gonna work or not. Okay. Alright, so let's open. Pip is the easiest way to install it. Will ship with Python. For other Python machines you can install manually. Okay, so let's open command prompt, I believe. And I think by default Python. By default, Windows doesn't even have Python. Oh my god. How to install Python on Windows? How to install Python on Windows? It should be very easy. So we need to go to Python website. No, don't update now. It's not the time to update now. Windows and its famous updates. Okay. Install Python. Download. We need 2, I think. Where is the? It will be here. Okay, when you see 2.7 fetch, alright, this guy. And Windows 64 installer. Yeah, that's the one we need. So let's quickly download this and install this while we are waiting. That shouldn't take long. This is a live tutorial getting things done for the very first time. Okay, so where does it go? Okay, it goes there as expected. Close that. I'm gonna close that also. Let's go check C. And while this is getting done, let's not waste some time. I can see it on my other screen. We're gonna bypass this for now. And we're gonna create a file cache node, which to be replaced by file cache 2 hopefully later on. So the way I have been linking these, so because this is pretty much the first cache simulation that is depending on this spectra, right? So here's what we're gonna do. Because everything in this simulation is driven by the shape of the waves. In order to keep that consistent, we need some kind of version linking so things don't get messed up later on. So what I'm gonna do is now I'm going to select my spectra node, click this gearbox, edit parameter interface. I'm gonna find this integer guy and drag and drop it to the root, then bring it back up as well, and then I'm gonna name it Spectra version in bold. Okay, so and then I'm going to copy this guy and paste it here. Okay, and on this file cache node I'm gonna do the same. I'm gonna create an integer. I'm gonna bring it all the way to the stop, and I'm gonna say Spectra version. Apply. Okay, so now I'm going to copy this, and then I'm gonna paste this here. And then what I want is a very consistent value all the way. So instead of going geo heap name, I'm gonna you might want to in my tutorials I change this to my cache 2 variable, which is my, I think it's 386. It's this disk. So every time I go a $cache2 like this, not like this, like this, not like this, like this. This is automatically fetching that information from that, remember, from that file that we did the environment under the username. There's Houdini 17, and then there's the Houdini NV, and here are my variables. But for now we're gonna leave it to $hip for tutorial sake, so it doesn't get complicated for you guys. And then I go geo. Now I want to copy this, and then paste this here, put a tab, and I will remove the heap name, and I'll put another slash after $os, and then I'll just go frame number bgo c, and then we cache it out. We can call this maybe bake OceanFoam. Bake OceanFoam. All right, let's see what's going on with the Python installation. Is not moving. Oh wait, it was waiting for me to. Oh, okay, sorry. It's actually almost done. And then so in order to show you guys what this is supposed to do, I'm gonna put this here because it should work. I'm gonna copy this guy just to test. Yeah, okay, it's working here. And let me now see if Python. Oh yeah, it has its own command line. Wow. Okay. So I'm gonna print. Hey. So we need to do a pip. Apparently, where was that? Okay, so we have the Python. So now after you install that, Python command line has its own command line, and there is even a UI of some sort. What is this? All right, so that's even a editor here. Okay, do you want the? Yes, I do want to kill it. Okay, so then it says use this to install Python. So I guess this needs to be in CMD because it needs to run. Right click, possibly run as administrator, and then oh no, I can't paste it here. That's ridiculous. From here to here, no. Copy, paste. Oh, okay. I guess we need to type it. We'll get HTTPS / bootstrap.py pa.io /get pip .py -o this guy, no, this guy, space python.error. We guys not recognize. How do you do this? Okay, on Windows, download pip in the command exec and install. Download pip, open command exec. Oh, okay. So I guess I just need to search from here. How to install psutil on Windows. Yeah, now it's just gonna install. Okay, we're just gonna follow these steps from here. On Windows, do this. We will. Can't open file, get pip py. Okay. Oh no, pip is on Windows. Download pip, open okay, sorry. I've been spending so much time in Houdini in Linux. I'm forgetting things. To install pip, securely download this guy. Okay. And where did it go? It went to here, I guess. Okay, so let's copy this guy into Python folder. Here, paste. I think now it will work. Okay, so doing something. All right, now it's gonna work, and we can test it straight in here also. Okay, and I think now we can post it to, so this is done. Okay, now we need to install psutil and install pip, permission using Linux, Windows. Okay, there you go. All right, cool. So let's open. Oh, I never activated it on here. Okay, so we'll have to do it after. Okay, so well, that's how we installed psutil. And if we open Python command line and we go import psutil, it doesn't error, which is good. And what this does is that I think we can do, will that work? I'm just gonna try something very quickly. Oh, it is working. Well, I could copy this, but so what this little thing does is that it prints out like memory usage and how much the memory is being used per frame, and later on we can use this, which we'll use this for recording our just for performance metrics. Like I like to do these things. It sometimes comes quite handy. Like I do my simulations, especially with this other tool that I'm going to we're going to build together in Python and Hython, and creating an advanced OTL. And using these little tricks, we are able to, I'm going to close Windows now, we are able to create little graphs and performance matrix, even like little Excel sheets or CSV files, so which works quite fine. Okay, so we were going to populate this, so what I will now, because I know that it works in Windows. So in Python, in Houdini, node equals who.pw itself, and this is showing the geometry node equals to node.geometries, and this is how you kind of, I mean, you should already know a little bit of Python for this to work, but keep in mind that in order to go through the tutorial, you can safely skip all the Python parts if you don't want to do it. These are not absolutely necessary to accomplish the tutorial. This is just a part that I use it, and it allows me to leverage some additional steps. The Python I'm showing here is not for data manipulation inside Houdini. For that, I think Vex is doing a great job, and we use Vex for most of the time. Almost, I mean, I use Vex 90% of the time. Python has its own advantages over Vex in certain areas, but the way I use Python, at least for this tutorial, is how to make this work. Basically, how to make your computer work while you're not at home. Kind of like an automated task manager for Houdini itself, and like creating a lot of variations of your simulations without changing a single parameter. It's like you may or may not know already that there is actually a wedger called Wedge, and I have never been very fond of the wedger tool. It's a bit complex to use. It kind of works the opposite. It kind of works like the overrider way. You put the attributes on this node, and then it's very confusing for me, at least. And then you need and then you look for, okay, where do I write the file names, and then you need to put a geometry node, and it doesn't work. Like, it needs to be here, it needs to be in a RobNet. It's a bit confusing for me. It has always been. So I said, okay, I'm gonna make my own, and so I did. So what are we gonna do now is that we'll continue. So actually we can change shape to this guy, I think. Okay, so now if I cache this out, it's gonna give me a version of the whitewater, but we are missing our boat. So let's fix our boat now. I'm gonna bring this guy up a little bit. So let's make a new network box. Apparently I wrote ship, but it's not a ship, it's a boat. So let's drop in a geometry. This is a Baltic B52 boat. Baltic B52. No, not the bomber. Yeah, Baltic B52 SL. No, it's, I think, one of these. Boat, yacht. It's called yacht. Yeah, like these guys. That's just a small boat. It's quite nice, but it's not very small. But maybe if I say yacht, yeah, I guess I did that before. All right, so these are some bigger ones. There's some smaller ones. It's a pretty cool boat. Let's name this guy to Baltic. Okay. And I have an alembic for this. So this is my model. You can safely distribute it. Do as you wish. And okay, let's see. So yeah, that's the model I have. So what I'm going to obviously release these files. I mean, they will be you'll be able to download them. So this was coming from Maya, and I had to do a lot of additional work on it. And what I'm going to do is that I'm going to copy the shaders that I created straight into here. Okay, so these are already, I tweaked them. It did nothing fancy really. We don't really have high resolutions or anything. And also I did a lot of cleanup on top of the Baltic itself. But what I'm gonna do is now, because this is its pure form, straight from Maya, and so I'm not gonna touch them here. So I'm just gonna say this the asset. And then because about and then what I did was I made another geometry node, and I call it Baltic render. My computer is doing something. I can hear it breathing. It's doing something in the background. It's doing something. I don't know what it's doing. Oh, I opened. What's going? Okay, let's close this guy. Why do I have so many? What is this? Oh, this is okay. Well, we done it. All right. Okay. Where are we? And then I have two of these again. Oh, I do. Oh, okay. 1 second. Sorry, I had too many files open everywhere. I'm just gonna close them. Okay, where are we now? Do I still have something? I don't. Okay, so we create another geometry node called Baltic render, and I'm gonna show you now what I did. So I don't want you guys to do it. So like I had to do a lot of cleanup. You know, blasting things and then creating UVs and everything. And if you guys want to see what I'm doing here, I will copy this as it is into the scene, and then I'm gonna create the collision parts and everything separately. But I'm not gonna go show you one by one what I did, how I create the UVs and everything, because not really the part of the tutorial. I don't want to add another 1 hour to the tutorial and say, okay, look, this is what I did, and then now it's 12 hours tutorial. So what we're gonna do is I'm gonna take it back here, and I'm going to copy this all the way to just before I started creating collision mesh, and then I have this clean version. So just did a cleanup, subdivided it here and there, and then created UVs so we can use them properly, you know, put some textures on it. Okay, so then obviously in order to have this model work for our collisions, I did additional work on it. So first thing I did was to load this file back, which is I had a different version apparently. Let me see that on my other scene. Okay, so this guy is here. I think they're the same exactly the same. Some texture work, maybe that's not from here. Okay, so we have this guy, and then I did put a transform under to just to lean it a little bit, and my values are 1.25, sorry, minus 1.25 and minus 19.7 degrees because of rough C. Okay, so that's like my initial pose. And then I create a time blend node because these might be called through simulations to have subframes, because we're gonna overwrite its position values with another file which I'll show soon. Okay, so I think they should be the same. So under this time blend, let's put a null and call it out follow, and then let's copy paste this guy. Let's call it out VDB. And let's create another one called out body. Okay, so under the just about the out VDB, let's drop in a VDB from polygons, and maybe enter the point one is, I think, probably fine. It was fine, yeah. Okay, so this just gives us like this rough area, which is fine. I'm just ignoring those small guys. Let's put a VDB smooth. Now this is just probably too strong, so I guess 2 iterations. So it just kind of gives us a little bit cleaner version of it. And then I'm going to put a blast for over the out body. And this mesh I prepared above has all these group names, so I'm gonna mask sails and ropes. So here it will be just this guy, and this should be good enough for our collision shapes, additional collision shapes. I think that's it for now, so let's leave the flag on out follow. But then how does this follow the waves? Okay, so we're gonna create something called another node called ship constraints geometry. Ship constraints. Let's go inside, and let's go inside here. So let's so what I did is that first of all I brought in the ocean spectrum, but we can manipulate this to be a bit better, maybe, I guess, but now let's make it clean. So let's create an object merge, and let's bring in the spectrum here. Let's call this in spectrum. And our ocean spectrum is coming from here, and this is our ocean spectrum. So this is our ocean spectrum. Okay, let's go back to where we were. Let's put another ocean preview. There's not really a point to go back, but I wonder. Okay, let's do it. Okay, so our spectrum comes here. Let's put on an ocean evaluate. Okay, now let's create another grid. 1000 by 1000, and a bit more rough res here. So what I'm gonna do now is that I think that should do. I'm just gonna resize this based on where I want my boat to be, which was in number camera 30 we were just seeing. It's roughly around this area, so I can make it now smaller. Not center. Scale. So I can put a transform under, I guess. And I just want this guy. Oh, too small. Okay, maybe like this. Yeah, that's probably fine. Yeah, no, this is good. All right, so now what I want is that I want to create a group that is roughly under the boat. So what do I do is that I have my boat here, right? So yeah, I mean we can try something else. Let's turn this off. We can bring the boat to somewhere a bit more visible, I guess. And then let's say, okay, let's bring this down a little bit more. So that's like our starting position. Okay. And then we can go back to ship constraints. So that's our place, right? Let's put a sphere. There are many ways to do this. I found this way to be a bit easier to use. So where is our sphere? There. So let's bring it under the boat. As a matter of fact, I think we can just use, if we copy this guy to right here, this should do the same trick. Should bring, yeah, that's it. Okay, because I want to create a little group inside the corresponding area. So let's change this sphere from primitive to polygons. Okay, I think we can make it a little bigger, like 1.3. Okay, it's there. Okay, so now I'm gonna group this area using bounding object. I'm not gonna change it like volume sampling and stuff because it's very simple. Bounding object, okay. And select one option on the point groups. Yes, that's correct. And now we should be grouping some stuff, because is it too low? Oh yeah, I think we also need to be probably just around there, so we can group some stuff, which is now 2 points. And at this section it's never moved, so it's fine. But now here we have a group, we have a point that follows. So now what I want to do is, so the waves are moving, right? So first of all, I don't want so high res, so I'm just gonna go downsample this to because I want to create a smooth surface for both to follow. Under this, I'm gonna put an attribute blur, and I'm gonna blur the position by 4 times, so even more smoother now, right? Then I'm gonna create new normals. This on points. Let me check the recording time. Okay, for fun is fine. Okay, now I'm going to blast. Let's hide everything else. I'm gonna blast everything but group 1. So it should give me, yeah, it gave me nothing. Okay, where is it? Am I not seeing it? Or let's go to geometry space. No, okay, they're there. Is they're just points that we're not seeing. Okay, so then that's 2 points. I'm gonna pack these into 1 point, which is gonna give me centroid, right? We don't need to pack this. We could create another point with a centroid. That's fine. But I'm gonna copy now this guy's normal to this guy. Actually, I want to see that, and I don't know why I can't see it. Oh, there. So I packed them. So now if I check the normal, that's probably fine, but I want to make sure that I am in good range. So I'm just going with the normals of these points. So was it the same before? They had normals now. The viewport breaks all the time. But okay, so that should be fine. It's looking up, you know. Okay, but now what we want is that I should probably show you this before and after. Okay, so now I want to, what happens if I now just copy the boat here? So that's what we want to see, right? So let's bring in an object merge. And we are gonna lock this guy into this object. And I want to go into my original Baltic because this is only for representation. Was it here or here? Oh, well, I didn't. Yeah, after I cleaned that up, sorry. What we can do instead is all right. Okay, so we still need this anyway. Let's continue with what I did before. I am going to, because we were fetching the rotation attribute, right? Okay, sorry, my bad. This was something I changed after. So now what I want to do is that I want to create an, I want to align and create a new rotation axis. So I can use those values from those points to here. Rotation. All right, so now if you follow me, what we're gonna do is that we're gonna create an attribute. Whoop. Plug this guy here. Let's call it rot. And dive inside. So now I want to align this to an axis, right? So I'm going to create a constant as a vector, and it's 0, 1, 0. And now I'm going to put an align from my custom vector to normal. Now I'm going to drop in an extract transform. I'm going to put matrix to X form. And now this is going to give me these values. And now I'm going to, I just need to check if the order, I didn't change any order. Okay, cool. Now I'm going to create an attribute, plug rod to rod. It's a point attribute and it's called rod. Okay. And so now it's it's an angle instead of a normal. Now the next thing we can do is in order for us to see the result, we need to bring that value here, so this gets transformed. And to do that, we're going to use a point expression that fetches values from objects. So it's just basically, we also need to transform. So in the translate x of any model that you want to deform using a point expression, type point, double quote, and we're going to go to our ship constraint slash the name of our object is rod, and then 0, and we want to get position, we want to get attribute x. So if I this should be correct. No, here a typo. Okay, so let me lock this guy here so I can show you. So it's 24.1748, exact same number, and that's how you fetch it. So now I'm gonna copy this, go to the Y, and now this needs to be 1. So it fetches Y attribute, and we'll do the same for Z, which is 3. And now we're gonna copy this guy again. It's also a vector, but instead of position, this time we're gonna type rot. So let's go to the camera. Oh, we pulled it to front. We need to put some here. And copy, paste 1, paste 2. Like I said, we moved it 2 forward. So let's put this back in front of the camera a little bit more, and I guess then it will be useful if we copy these parameters to where the ball is, so it updates properly. Okay, so now I'm gonna hide environment. I'm going to visualize Ocean Preview. Oh, this is broken again. Breaks. It's very annoying. Time for a new video card. Okay. If I will color this also. I colored this guy red. I colored this guy black. I wonder if we can see a low res version. Maybe. Okay, I'll do that so it's a bit faster. Let's hide this. Let's turn this on. So now if I hit press play, our boat will move based on the normals of the ship, but it's gonna do this weird things, like it's gonna go click click. It's not gonna be smooth, so we need to smooth that out. Then let's just check if this is still in the good place, because we moved this guy also. Let me put this back into position 0 where it was before. Opa. To avoid some surprises, and maybe if you want to change the values, I'll change them after. And it was a little minus 1 point. Minus 1 meter 25 centimeters down as well. Okay, and it was 0 and 19 degrees off. Okay, so let's go back here. Space guy. Okay, and if I play now, yeah, so it's very strange. It doesn't seem to be working, but it is actually working, because it should be blowing this guy up, and these points should be under there, and this should be the output. If I put these guys on here, okay, we are reaching 54 minutes. Need to probably stop and continue with another video if we cannot squeeze it in. So 1 second. Okay, so I think one of the problem was the uniform scale was 2, so I just made this a little bit bigger. Now it seems to be better. It's just a little more accurate, but it still has the problem, right? It's so this is a deformation object, and that the we are visualizing the Baltic render that we constrained to. So if I play this guy, yeah, it's moving, but if I do a play blast, you'll see every now and then it has this tick hard motion that it's not desirable. So what we're gonna do now is that, because under here, just like before we after we delete all the geometry and copy the normals, and this is the part where there is sometimes there are sudden shifts, and we can use ChopNet, which is not very popular, I believe, but it's actually very, very useful, and I'll show you how this works now, to actually go over the frame and get the numbers out and then do some mathematical operations on top of the keys, basically. So now I'm going to pull a null here. Let's name it to chops, and I'm going to put a channel sop. And now, because it's not fetching anything and it's automatically broke pretty much, because we need to fix it. So what I want is that I want to manipulate the normals, right? X, Y, Z, that's fine. And my attribute scope is now normals. So this goes inside the ChopNet, and this is what we want to fix. And it's animated because it changes over time. And then I'm gonna put a null here again, and I'm gonna call this out ship animation. Out ship. I'm gonna copy paste that cheated. Okay, so let's put on a ChopNet now. This is a very simple ChopNet example. So we're gonna put a geometry. We're gonna put a geometry node here. Let's lock this. So to SOP, it goes this guy. So the one we defined here, attribute scope is n, and now we are dividing these into 3 separate attributes, and x, and y, and z. And again, it's animated as we defined. And thing, you need to keep everything the same. Yeah. So now here's the thing. You can actually, I believe, so now it should work, but okay, yes, sorry. And then here, let's lock this guy. We need to put a null in here, let's say. So we're gonna put stuff inside. Let's call this out. And let's bring this guy here. Now this is gonna calculate the whole, what is this, 300 frame? But it's not gonna do anything yet because we didn't put anything in here. But now we'll see. Let it go for a while. Okay. And I think we should be able to see the motion effects. Where do I see? I don't even remember anymore. Here? Yeah, I guess so. I'm not sure. Okay, so now what we're gonna do, no, I have to find it. Where is it? It was supposed to be here, no? Option sample seconds, because that's the whole idea. Or maybe I need to select this guy. Okay, maybe. Alright, yes. Yes. Okay, so now let me make this a little bigger. So look, this is the current 3-axis normals that throughout the frame range. So let's go here, and you see sometimes it's doing crazy spikes, and we don't want that, obviously. We want to fix that. I wonder if we can put, oops, no, we don't want you, no way. Where did it go? bring back my seconds. No, I want the frames. No, this is minus. We are lost, guys. Is this the frame number? Oh, okay. All right. Okay, so now I want to smooth this out, right? Yeah, I just want to show it a bit fancier, but I guess that's fine. Okay, stop playing. All right. So there are a few nodes available here. There's a lot of audio processing here, but then audio processing has a lot of cool stuff as well, and which you can apply back. So if you want to treat this like a sound wave, you actually could, and this would eventually end up driving the animation. But now what we want is, first of all, we want to filter this, and I want to filter this Gaussian, and the effect value is 0.7278, and filter width is 4 and 4. So now what did it do? So it kind of smoothed it out, as you can see. And if I play this now, it's better than before. It's not perfect, but it's better than before. So that's why I can go, I don't know, all right, maybe, yeah, there's the effect value of 1, maybe even 2. No, 2 is breaking it. I guess 1 is the perfect value, because the boat will pretty much never bump it up like that, right? So we can go maybe 2, and if you look from the side view, and let's bring in the waves. Where are the waves? Here are the waves. Okay, so if I play now it should feel like much more natural. But here's the thing, we're still missing something which is pretty cool. So when there's a big wave, so the boat always reacts a little late. So like the nose will sink, and then it will come out, and that's the lag. Okay, so that's the lag. And to apply the lag, and there's actually a node called lag, so which we are gonna plug it in as well, and we're gonna lag by almost a second. And if we play this now, everything should be shifted a little bit more, so we might see a little delay in the response times of the ship as opposed to the water itself. Okay, so I'm gonna close this guy now, go down, close this guy, let's look from the camera, and if I press play, and even maybe do a little play blast. So I'm gonna disable these guys, and let's put in maybe this wire shades, and let's do a little flip book. And after this section, I will pause the video, and we will continue with the. I think we should continue next lesson with the awesome, exciting Python episode. All right, so now this is. I'm gonna save this, and now I'm gonna turn on the filter, make another daily flipbook. I keep saying play blast because it's just it's stuck to me from Maya, and no regrets there. Maya has been awesome for a very long time, but for some reason I still keep saying it play glass instead of flip booking. So let's bring in both images side by side. View, lay out 2 columns. Makes it a little bigger, right? So, and one of them is, these are still the same. So you open the sequence list and you hit your mouse somewhere, and then you say, okay, show this. This is the old one. This is the new one. So if you play, so pretty much all that stuff is fixed now. So this, you can apply this to everywhere. You can use this chops method for so many things that you can fix, improve, add some Gaussian, fix Euler rotations, etc. And if we add the lag as well, so we know how that works in the end also. So let's make another flip book. Okay, almost there. And we're gonna need 2 rows. And this guy. Okay, so I'm gonna stop and open the sequence list, and this guy is gonna be the last one. Now this is the last one. Is this, and this is this. They're all different. No. Oh, it crashed. Oh no. Okay, mplay crash. That's fine. Let's save our file. Okay, so I think we can leave it there. So now we have a boat, we have an ocean, we have not cached our simulation yet because we're going to do that after the Python lesson. Next few lessons will be about, if we need to recap, will be about creating we will be creating ocean sprays from the cusps, but to do that very good, we better do the my file cache 2.0 Python lesson first. Then it's going to be more easy. Well, we don't need it, but I prefer to get that out of the way so we can continue. I think after that we can break the mast, this mast, and do some vellum. And finally, our ocean simulation and the white water and the wet map. And on top of that, we're going to do the additional atmospherics against the mist and the clouds. Okay, so I'm gonna stop the video now, and then in the next lesson we start the Python.